Okay, so logarithms, 3.3 properties of logarithm. So a couple things to remember, a couple of the rules, rewriting logarithms. So definitely take the time to go over these. So property, well, the first one is change of base. So log base of a of x is rewritten as log base of b of x over log b of a. Base of 10, so log of a of x is log base of 10 of x, log base of 10 of a. And then to base of e, so log of a can be converted to ln of x and ln of a. Okay, so first things first, rewrite the logarithms as a ratio, a common logarithm, and a natural logarithm. Then evaluate the logarithms, round your answer to the three uh, decimals. So for this one, as a ratio, this would just be log of 4 over log of 7. And all you'd have to do is write, just put it in the calculator. So just log of 4 divided by log of 10. Oh, sorry, log of 7. And you should get 0.72 because it says round it to your nearest. Yeah, exactly. So should yeah. Uh Another way you could rewrite it is also ln of 4 over ln of 7, and you'll still get 0.712. Oops. So ln of 4 over ln of 7. So do the next one. Log of 64 divided by a log of 1/8. And all you have to do is just use a calculator. Yeah, you're definitely gonna need a calculator for this. So for this one, you'd actually get -2. Yeah, I mean, some of these you could do in your head. Sorry, do it by hand, but not all of them though. For natural log, ln of 64 over ln of 1/8, and that'll give you -2. Mm. Yeah, these ones are my favorite. Properties of logarithms. These are the following rules. You have the addition property, quotient property. I was gonna say division, but it has a fancier name, and then the power property. So they're pretty straightforward because you did learn these in math 3. Did you guys learn these properties in math 3? Yeah, okay. So I won't really go over them that much. So it says use properties of logarithms to rewrite and simplify the logarithm expression. So this is multiplication, so we're gonna rewrite it as addition. So log base of 2 of 4 squared plus log base of 2 of 3 to the power of 4. And then we can use the power rule, take the exponent, bring it to the front. I'm sorry. 2, and then we can simplify as much as we can. The only one that can't simplify is this one right here, because you can rewrite 4 as 2 squared. Use the power rule again. Simplify. Now, the only one that can simplify is log base of 2 of 2. Do you guys know what you'll get when you take the logarithm of itself? Yep. So then the final answer would be 4 plus 4 log base of 2 of 3. And that is your final answer. So you kind of have to know the properties that I gave you from last week. One page of those. Mm. On another hand, so log base of 2 is log base of 2 divided by log of 2, which is 1. So remember, anything divided by itself is always 1. So when I rewrite log base of 2, it's just log of 2 divided by log of 2 since they're both exactly the same. You're dividing anything by itself will always be 1. Any questions? Okay, so the next one, same thing. So this is going to use the quotient property and the power property minus, then do the power. Oops. And then from what we learned, ln of e is just 1. So that's one of the properties you have to know. So this is means ln of 6 minus 2 times 1. And I know you can just write 2, but I always want to get in the habit of always, when anytime you're substituting or plugging something in, you always want to write it out and then simplify. All right. The next page. So you guys need to know also how to rewrite radicals. So the square root of x can be written as x to the 1/2. X squared is x times x. The cube root of x is x to the power of 1/3. 49 can be written as 7 squared. When you take the square root of a square, it's just the base. So in this case, the answer is 7. And then the reason why that is because that radical can be written as 1/2. So 2 times 1/2 will give you 1 using the exponent rule. When you're multiplying exponent by an exponent, you're multiplying. So that's how you get 1. So you guys have to know how to rewrite radicals. So for number 10, use the properties of logarithms to expand the expression as sum, difference, and or constant multiple of logarithms. So log base of 10 plus log base of 10 of z, because we can break apart the variable with the constant. So that is the addition rule. Now log base of 10 is just 1. Or you can rewrite it as plus 1 and have a constant in the back. But either one is perfectly fine how you rewrite it. Hmm. Number 28, using the power rule. You just bring the exponent to the front, and that's it. You can't go any further than that. 32. And so we're going to do the quotient rule first, and then use the power. And that is the answer. When you do the expansions, you remember you always go left to right. So since we're adding and subtracting, it always goes from left to right. So then when you do this, you'll do 11x times ln of y, and that's how you get ln xy. So going backwards. And then since this whole product is subtracting from this variable, and then we're using the quotient rule, this z is dividing by both x and y. So this is ln of x divided by z. So just know that those both have to be yeah, in order from left to right.
If z was in front of y, it would just be only dividing x then?
What?
If z was ln of z was in front of ln of y, would it be only dividing ln of x?
Yes and no, because so if you do ln of x minus ln of z, right? When you simplify those, that'll be ln of x divided by z. And then ln of x divided by z times ln of y will be xy divided by z. So that's still perfectly fine, as long as it makes sense. So I'll still read out perfectly. But ideally, the quotient is always in the back. This one's just in the back. But it's not wrong if you put it. There's certain circumstances where it won't be the case. So when it comes up, you'll see it. All right, so number 36. So for this one, rewrite it. So ln of x squared over y cubed to the power of 1/2, right? Because they all have the power of it. Now, to do this one, you're gonna have to do the product of product. So you're gonna have to distribute to both of these together. So that way you'll have ln of x to the power of 1 divided by y to the power of 3/2. And then you can just do the quotient rule after this. So ln of x to the power of 1 minus ln of y to the power of 3/2. Since this is just to the power of 1, we don't have to do the power rule. And that would be your answer. Does anyone have any questions? There's also another way you could do it, but this is honestly the shortest way to get to the answer. There's a longer way of getting to it, but you don't need to know it. Unless you really want to know it, then I can definitely help. Number 50, condense the expression to the logarithm of a single quantity. So this would just be the power rule. 5/2. And that's it. You could technically rewrite this as well. Um, to have the radical sign.
Either way, right?
I think the book, yeah, I think either way is right, but I think the book has it written in this way. But yeah, technically they mean the same thing. Honestly, this is just a nicer way, especially when you do the next problem. So for this problem right here, you're gonna have to do distributive property first. Well, technically, you don't necessarily have to because you can technically write this as 4 bracket ln of z times, or in this case, just write z plus 5 bracket minus n ln of z minus 5 to the power of 2. Then you're going to do the power rule. Ln of z to the power of 4 parentheses z plus 5 to the power of 4 minus ln of z minus 5 squared. So power rule has to go to both of them, not just one of them. And then since we're doing subtraction, it's going to be the quotient rule. This would be your final answer. But
Well, then maybe I'm not. Not that background, that's just the motion rule.
Yeah. Technically, no, I won't tell you because because it's
Please make our, movies uninteresting.
because think about it this way. Do you really want to know? No? Okay. So, okay. How can I rewrite minus as a positive? And explain subtracting, how can you make it a positive? Right? So I can put plus negative, right? Then what's the power rule then?
Oh my God. Why? Wait.
Negative two, right? Because you're bringing it back to the top.
Yeah. Oh, you brought the L in, no, that's fine.
And then so it's the addition, right? So it's gonna be product.
Put that notes.
Oh yeah, you're right. You're right. Okay, yeah, you're right.
It's like looking at that for a second. I was -1 maybe,
Yeah,
but I
sorry.
thought that was the L
Yeah,
in.
yeah. You know what? You guys don't have to write this one down, by the way. Now, since what's it called? It's since it's addition, right? So then you're gonna be multiplying z minus 5 negative 2, right? How do you rewrite negative exponents?
One over, one, or, yeah, 1/2 where L in is. Correct.
Right? You still get to the answer. But why would you want to do that if you can just do the
It's nice to know.
I like it though. I like it. It all just makes sense because you can always rewrite stuff and make it look definitely a lot nicer. And that mentality will definitely help you for second semester of pre-calc.
I, listen,
Because there's more than one ways to get to the answer, but your logic has to be correct. You can't just start making up stuff and then and then be like, nope, that's just not how it works. And trust me, it's honestly the hardest part about teaching pre-calc is telling you that's not how it works. And then me trying to explain to you is just like it's like it just doesn't work like that, you know. So
things that feel like it makes sense.
yeah. Exactly. So you just have to be, and it honestly will be reflected on how much you understand from previous information because you rewriting negative exponent is something that you guys learned in math one, and you can apply it to now. So like a lot of people still struggle like how to rewrite negative exponents, right? Rewriting negative two as one divided by z minus 5 to the power of 2, right? So it's just, gotta make sure you know like that's just the rule for it, in terms of mathematics. And I end up applying into like right what you guys are learning right now. So you guys didn't have to write this one down. That's completely up to you. Number three, sorry, the last three, and we're almost done. Find the exact value of the logarithm without a calculator. So log base of 2, right? How can I rewrite 8 in terms of 2?
It's just that log base of 2 to the power or to 8 or log base 2 8 equal x.
Nope.
That's not.
Actually, you can, but you're kind of doing it the long way.
That's the.
Yeah.
Oh. Who's that?
That makes sense. Your long way is not wrong, but it is perfectly fine. So now you gotta figure out what 2 to the power of 8 will give you. So technically, exactly. So, so both ways work. But the thing about this one is you kind of have to know that I need to find a common base of 2 because I know when I take the log base of 2, this is gonna be 1. So that's how you get 3. But technically what you said equals x is perfectly fine. I would probably do that if I didn't remember what's it called, the rules for it. And that's why for your notes, I highly encourage you to have the rules for them if you don't have them already memorized. This one right here. So same thing.
That's most certainly wrong on the guess. You're gonna use the rule of additions, essentially -1 exists. Yeah.
What?
Would you use the additions property? For
For this one?
Yeah, you don't have a choice. You gotta take that negative out. It would be -2, wouldn't it?
Yeah.
You have to take the -1 out. There's no exponent for negatives. Unless you wanna go into imaginary numbers.
Oh, okay, I see what you mean. So for -1 times 16.
I mean, you could just look at it and tell, but I mean, I think if you want to, you have.
Actually, no, this one has no solution.
What? You can't take it out because it's still
Yeah.
invalid.
Yeah, it's invalid. There is no answer for this.
This,
Yeah, it's no solution. 4 to any power will never give you a negative number.
that's what I thought, we did -2. It's like,
Yeah, because I'm looking at
oh,
it too. Yeah. You can't take a log of a negative number because it's out of the domain. It's us because remember what the graph of a log looks like? Looks like that. You can't have negatives. It's outside the domain. So this is actually a trick question. No solution outside of domain.
No, not gonna be fair, I believe that you're trick question on.
And actually, I was trying to figure out solve this by hand too. I'm like, wait a second. No matter what, you can't take out that negative number.
I plugged it in and looking myself.
No, if it was -2, it would be 1/16.
Yeah. Which doesn't work.
Yeah, exactly. This one has no answer. The next one.
What do you mean?
Yeah.
No, that doesn't. Or sorry, -2, or wait, no.
Oh no, you can just do the rules for this.
Yeah. Yeah. Oh, what's that? Wasn't the wind? The wind's gonna be very loud today.
So the answer is -4. What you could have also done, and is actually condensed it, was you guys could have done ln of e to 6 minus ln of e to the 10th. And then this is the quotient, right? Oops, ln of e to the -4, and then use a power. You could have also done it this way. You could have condensed it and simplified. Remember when